security. Now, I'll cover three things. One is the current threat landscape. Second is current AI trends, and thirdly, the potential impact on cybersecurity. To begin with the current threat landscape, you have to understand the categories of threats today. On a high level, I've put this into two categories: consumer focused threats and then enterprise focused threats. Consumer focused threats are essentially threats that are targeted towards common person, somebody who's using a online service, who has an online presence, is, for example, banking, buying an something from an online shopping portal or an app, or anybody who's got a digital presence. Whereas on the enterprise specific threats, these are targeted towards organizations that are producing goods and services. These could be banks, a manufacturing company, this could be your college, university, etc. Okay, and today everyone has a digital presence. Now, threats that are focused towards consumer are most commonly fall into the categories of malware, which is essentially in a simple term known as a virus. Then there is phishing, smishing, wishing, and essentially these are messages or emails that lure a user to give up their credentials or anything that can help the scammer or cyber criminal to extort money or even steal personal information, empty the accounts, or cause any sort of financial damage. The third type of threat, which is very common nowadays, especially in the last 3-4 years, is ransomware, which essentially ensures that your system is encrypted and you have to pay some money to the cyber criminal to get access to systems. And sometimes they don't even give access, they want more money, and they try to extort you by exposing the information online. Okay, crypto mining is another very common threat. So in this case, attackers don't do any direct damage to you, but they would use your systems like mobiles or laptops, which are very powerful, to mine cryptocurrency, which benefits the cyber criminals. And then the entire thing around misinformation by creating fake audio, fake videos. And similar kind of threats exist for enterprise. They're more sophisticated in nature because the volume of money and the brand damage is much higher. So things like spear phishing, which is essentially a tailored email, which is more targeted, looks more personal to the victim. Then there is business email compromise. Then DDoS, distributed denial of service, which impacts the service delivered by an organization. Example, take a bank which is dependent on the online website for a 24/7 banking service. Now, if a bank's website could typically take, let's say, 1,000 requests per second or 1,000 consumers per second, suddenly a cyber criminal sends them 1 million requests per second, and the bank's website can't handle it and it goes down. So this could be considered as a DDoS attack. Then a very common attack is a software supply chain. In this case, software which is used by this organization can be compromised by the cyber criminal, and once the updated malicious software is used by this organization, the cyber criminal get access to the target organization. So this I covered in my recent podcast on a specific attack called 3CX, and there have been multiple incidents like that in the past. Then there is again crypto mining, same concept, using corporate assets to mine cryptocurrencies. Attackers are going after the cloud exposed assets to mine crypto if they can breach those environments, and that happens if they're not properly configured. And then there's an entire threat around data loss, data mishandling, data exposure, and insider threats where disgruntled employee can expose data and or could do damage to the corporate data or infrastructure. Okay. Now, for each of these threats, there are typically cybersecurity products present today. They've been there for a long time. So, for example, banking uses transaction monitoring quite often. They use fraud detection, they use phishing detection, and there are companies that provide those services. Also, endpoint security or endpoint protection platforms are very common. for consumers. Now you can get them on your mobile phone or your laptop, desktop. Similarly, more sophisticated products and services are available on the enterprise to prevent the entire corporate infrastructure. So things like network security, endpoint security, application security, they exist today, along with the security monitoring platforms like SIEM, EDR, NDR, UEB, etc. Now, all of these platforms are using AI based algorithms today to improve accuracy for both prevention and detection. So it's been there. In fact, fraud monitoring, transaction monitoring has been using it for over 2 decades to my knowledge. Okay, and AI is getting used more often in newer products. So that's the current landscape. Let's look at some of the AI trends. Now, AI based applications have been in common use since last decades. NLP based applications are very common. Essentially, they process your voice, text, and images, and the idea is very simple, that a human's language can be converted into a computer instruction. So a simple could be voice-based search or a voice-activated device like a Siri or Alexa, very common. Same goes with not NLP, but Google Maps also uses AI. It can also use NLP if you are giving a command, a voice-based command, and that gets translated into instruction into Google Maps and so on and so forth. And now, last 6 months, generative AI, which takes a text, image, or a voice, and it can, using that data, it can create new content. Okay, that's why it's called generative AI. And then, because of this massive explosion of generative AI, there are new apps that are coming that are trying to target use cases. So, example, I recently tested an app that helps me edit my podcast using AI. I can create voice memos, do speech synthesis, create music using AI-based apps. Okay, I can build my own chatbots, and then there are plugins that are coming in that are using AI to give recommendations, etc. They can generate summary of the content, they can verify the sources of this content, etc. And because new tools are coming up, the developers of those tools are also publishing new websites and domains, and new businesses are coming up. In April alone, I heard about 2,000 tools that got published in 2023, April 2023. And because new tools are coming, a lot of users are testing them. I've myself tested around 10 AI-based applications across various use cases. So number of users will automatically increase, and this is eventually leading to growth in the compute resources, because these AI-based apps need a lot of backend computer power. So there's growth in computer infrastructure, and of course growth in data. As AI needs more data, users are uploading more data to have better output. And all these applications are again using API, which is a way for applications to transact and share data. So example, if I want to write my own app that takes input from ChatGPT, I will create an API in my app that will talk to the API in ChatGPT, and then the end user of that app will never come to know about the use of ChatGPT in the background. Okay, so that's very common now. Now, with all this happening, let's look at the potential cybersecurity impact. So I've categorized this into 9 potential trends that can happen in cybersecurity. Let's start with the first one, which is attack on the ML models themselves. So there are 5 categories within this. One is the adversarial machine learning based attack. So essentially, it's all about fooling the models through the use of malicious input or deceptive data. So there was a case study where a 3D printed toy turtle had a specific texture, and it fooled the Google's object detection AI to classify it as a rifle, which means it could do a wrong decision. And it didn't matter, whatever angle you take the picture, the turtle was still considered as a rifle. Another example that was published is that a machine tweaked image of a dog was shown to look like a cat, and it fooled both computers as well as humans. Right? So that's a possibility. The second kind of attack is evasion-based attack. In this attack, the data is modified to evade detection, or it can be classified as legitimate. So example, you might have seen sometimes the spam lands in your inbox, regular inbox, instead of a junk mail, right? So typically all the mailboxes, or most free mail servers have a spam detection logic, but attackers are still able to bypass it, and this is essentially a kind of evasion based attack. The third category of attack is the model stealing. In this case, the cyber criminal or anybody with the malicious intent can probe the ML system to understand the model that was built, and also there's a possibility to extract the data. The very useful in case a company is building a proprietary model and a competitor of this company can run some tests and figure out what this company is trying to do, right? And maybe they want to replicate it in their business model. And then the data poisoning one, which is essentially because AI algorithms get trained on data, and if there is bad data in the mix, the subsequent output or the retraining process could lead to bad results. And then the last one is the rogue/trojanized model, where you can expect that a model promising something doesn't deliver it, or even if it delivers, it also does something malicious in the background. The reason I'm citing this example is because on GitHub there I've seen projects, a lot of AI based projects, a lot of people are testing it, but we don't know what that model is eventually doing. We don't know that code. We have not written it. Somebody else has written it. AI itself is writing code. So it's you don't know what that model will do unless you fully test it. So that's a threat. The second category of impact would be on the compute side, because there are new systems will be automatically provisioned. New businesses want to test AI. They want to launch AI based products. And this is security is an afterthought in most cases. So they will in the hurry to launch new products, they will set up infrastructure, and eventually that will mean increase attack surface for cyber criminals to breach those companies. And I'm sure we will hear about those breaches soon. Okay, whether it's leading to software vulnerability, infrastructure vulnerability, configuration issues, etc. The third type is the data loss around data because of exposure of data. I'm sure we will hear about cases where loss of sensitive data will happen because of accidental exposure. And then API-based attacks, because API will constantly be used across applications. You will hear things like credential exposure, DDoS, unknown APIs, account takeover-based attacks, or breaches. Okay. Also, because new plugins and new apps will be there, you will see fake plugins. You will see new website domains getting hacked, similarly new fake apps or rogue apps with a promise to give something, but eventually they would want to steal information, extract end user information, and also use this information to carry out further attacks or do identity theft. Okay, and because number of users are increasing, you will expect more credential thefts, breaches. Okay, and in fact I'm already seeing examples in where ChatGPT premium accounts are available for sale, either using a stolen credit card, or they have themselves, cyber criminals have been able to get these accounts from genuine users by using social engineering or phishing based attacks. Okay, and of course the use of AI tools for cyber attacks. So with deep fake and essentially creation of fake audio and video, and in fact the capability to voice from an influencer like a genuine voice, it's very much possible that anybody can do an authentication of a voice. So recently I heard a rap song created by ChatGPT in the voice of Eminem. Eminem didn't sing that song, but algorithm created it, which means anybody can use this type of algorithm to get authenticated to a banking system that uses voice to authenticate. Okay, so these things will grow massively. Okay. Also, another way to look at it is because there are infrastructure and apps in this on a high level, there are two categories of layers in this. There could be infrastructure attacks as well as app-based attack. So example, somebody creates a new app, launches it on Azure or AWS, and they haven't properly configured the servers. Attackers can get in, they can steal data, they can steal the code. Same issues that we have for ages, they will always be there. Okay, and all these attacks are applicable to this entire supply chain of AI. Okay, so quick takeaways. Cybersecurity and data privacy will be more critical than ever because of increasing use of AI. New laws and legislations will be formed to handle issues around data, algos, and copyrights. I expect this. And also, what that means is we should learn more about cybersecurity, how APIs talk, how app security works, how cloud native apps work, how data security works, and other relevant topics. So keep learning,